Okay, so we just talked a little bit about and looked at an animation that showed us that when we're given two sides and an angle that's not between them, we're not guaranteed to get a particular triangle. And we talked about this when we learned how to prove triangles congruent last year. So sometimes it works, sometimes it doesn't. There's three possibilities, which is what ambiguous means. It means we just don't really know. So you could get one answer. There could be one triangle. It works great. Sometimes it doesn't work at all. You can't even make a triangle. And sometimes there's two possible answers. There's two triangles that are possible with two sets of angle and side lengths. And so if this is the case, we're going to have to give both possible answers. And the key to how we're going to decide whether something's possible or not is knowing that the angles in a triangle, I'll put a little triangle there, add up to 180 degrees. So it's called the ambiguous case because it's not clear-cut. You do have to do a little bit more thinking, but we are still using the law of sines. Okay, so to look at our examples, I'm going to start with number 1. It says in triangle RST, the measure of angle R is 80 degrees, little t is 17 kilometers, little r is 12 kilometers, find the measure of angle S. They're not going to give you a picture on these because the triangle may or may not exist. There may be two triangles, so you have to draw your own. So this is triangle RST. We don't want to use a lot of room to draw the triangle. I'll just draw a triangle over here. You don't want to make it look like anything in particular. We do want to label the corners R, S, and T. So I put R on the top, S and T on the bottom. And then across from those, you would have the lowercase letters. So they give us lowercase t, so the measure of angle R is 80 degrees, so we can write that in. This is 80. And then lowercase t is 17 kilometers. So lowercase t is across from capital T, so this would be little t, and that is 17. And then little r is 12, so that's across from the capital R. So R is 12. And that's kilometers, but for the sake of my picture, I'm going to leave that off. Zoom in just a little bit. So we want to try to find pairs of sides and angles in order to do the law of sines. So we look at the information that we have. We have 80 degrees for angle R and 12 for side R. So those go together. And then we have little t, side t over here is 17, which means that I have to first solve for the angle T. Even though in the directions it says find the measure of angle S, I don't have a way to solve for S. I don't have the side across from S. So we're going to solve for the one that we can first, and then we'll use that to find the other information. So if you remember law of sines, the sine of the angle always goes across from the side. So start with the pair that you have both numbers, the 80 and the 12. So sine of 80 degrees over 12. And this is where it's going to be different than the previous lesson. We're going to have sine of angle T over 17. So instead of giving us two angles and a side, they're giving us two sides and an angle, and the angle is not between them, which makes this a little bit more interesting because we're solving for an angle. You do still cross multiply, so we'll do this, and we get 17 times sine of 80 degrees. And then when we cross this way, we get 12 times sine of t. And you want to solve for the sine of t, so you divide by 12 on both sides. And when you put this in the calculator, it comes out approximately 1.395 is approximately equal to sine of angle t. So we have to figure out what angle t is to do anything else, and then if it works, we can find angle S. So we find this by using inverse sine. Inverse sine of 1.395 would give us angle T. But if we put that into the calculator, something interesting happens. So let's see what that looks like. So we do second and hit the sine key. Put in 1.395. And we get an error. And your calculators might not say quite everything that mine does, but it gives us a domain error. The value entered is not allowed for the function. So basically what it's saying is you can't have sine of 1.395. It doesn't work. And when you encounter one of those, basically you're just going to do a big fat no solutions. When that happens, you just know that it's not going to work, and you basically stop there. So if it had worked, we would have used that angle to find angle S, but it didn't even work out. So once you get to that point, you just stop, and that's it. Okay? So that one wasn't very exciting, but we got it set up and figured out that it doesn't work, so that's still progress. Okay, so if we go over to number 2, we have a new problem. It says in triangle BCA, so let's draw that really quick. And I'm going to put C up here and B here and A there, except I started to write another C. So BCA, just as long as you have A, B, and C on there, you'll be fine. Your picture doesn't have to be the same as mine as long as you put the information in the right places. So this is measure of angle A is 29 degrees, so we'll put 29 degrees in there. Little a is 31 miles, so little a is across from big A, so this would be 31. So that's A. And then little c is 29, so little c is across from big C, so that's 29. This is side little c right here. So we look at the information that we have first and try to see what we can pair up. So the 29 degrees is across from the 31. Remember, they have to be across from each other on the triangle. And then the 29 that we have is across from angle C, which just so happens to be the one that we're looking for. Find the measure of angle C. So then those go together. So we set up the law of sines. So sine of 29 degrees over 31 equals sine of angle C, which is a capital C, over 29 miles. There's too many 29s in that problem, but I didn't write it. I just randomly made it. Okay, so we cross multiply. So we're going to have 29 times sine of 29 degrees. And then that equals 31 times sine of C. We divide by 31 and put that into the calculator, and it comes up 0.4535, and it keeps going. So you could just keep that number on your calculator. It's approximately equal to sine of C. And then to figure out what the angle is, we can do inverse sine. So inverse sine of 0.4535. We actually get an answer. And we put that up here so we can, so we're going to do inverse sine of 0.4535. We get 26.96. I'm going to go ahead and just round that off. It says nearest tenth in the directions up here, but that's just going to round up to 27 anyway. So we'll just say 27 degrees. Now, here's where it gets a little bit exciting. We know at least one triangle exists that has 31 degrees for A, 29 degrees for angle A, and 29 miles for side C. But there might be a second one. So I'm going to teach you how to check for the second triangle. So check for second triangle. And what you do is, if there is a second triangle, this angle would be a supplement to that angle. So you find the other possible, other possible measure of angle C is going to be 180 minus 27, which gives us 153 degrees. And then we see if that jives with what they originally gave us. So we had 29 degrees up there and 153. If I have a 150 degrees, 53 degrees, and 29 degrees, and just add up those two angles, I get 182 degrees, and we haven't even put in angle B. You can't go over 180. So since this is bigger than 180 with just two angles, we're going to say nope, on that one. So this is going to be my only answer, is just the 27 degrees. If you get a second angle that works and you can stay under 180 in the triangle, then we would box that one too and say this is another possibility. So if one works, you always have to check for another, but you always just subtract from 180 and then use a little bit of knowledge knowing that your triangle is going to be 180 or less. Okay, so let's go down to number 3. So in number 3 we have triangle ZXY. And I just poked a hole in my paper, but it's all good. So I'm going to put Z right here, X at the top, Y here. Like I said, it doesn't matter as long as you have all 3 letters on there somewhere and you mark it like they say. So the measure of angle Z is 42 degrees. So I'm going to put 42 degrees there. Side Y is 25 inches, so that'll be across from angle Y. So here's angle Y. That means that this 25 is going to go over here, and that'll be lowercase y. And then lowercase z, side Z, is 22 inches. So here's angle Z, and then, so this 22 is going to go over here, and that's the same as side little z. Okay? Put a little z under there, although my 2's and z's look the same, so it's just going to be confusing. All right, so you want to find a pair that goes together. So 42 degrees is across from 22. And 25 over here is across from angle Y, which is the one it says to find. Find the measure of angle Y. So this should be pretty straightforward. So we would set up our law of sines. So sine of 42 degrees over 22, making sure we keep those together, equals sine of angle Y, capital Y, over 25. So setting it up is very similar to yesterday. We're just solving for an angle instead of for a side. So you cross multiply 25 times sine of 42 degrees equals 22 times sine of Y. And then we divide by 22. And you will get about 0.76 something. I'm going to type that in because that's what I have written down, but I don't remember. 76037. So that's why I must have just rounded off. So that's about what it is. I would just leave that number on your calculator. You don't want to round things off too much before you get to the end. And that's approximately equal to sine of Y. Oh, I know what I did. I didn't divide. Okay, so when you have this number on your calculator, an easy way to just put that in is go second sine, second answer, which is where your negative key is at the bottom, and then you don't have to round anything off. It'll just use whatever the calculator has. And so this comes out 49.49. Since it says to round to tenths in the direction, I'm going to say it's 49.5 degrees is angle Y. Okay? And so we know one of them exists because it worked. So then we're going to check for the other possible answer. So we're going to check for a second possible triangle. So the second possible triangle would be, so for the measure of angle Y could be 180 minus 49.5. And when we do that, we get 130.5 degrees. And we just need to see if that would work with the 42 that they originally gave us. So if I add 130.5 and add 42, that comes out 172.5, which is under 180. This is the test. If it's under 180, then that means yes. And this is another possible measure for that angle. So this angle Y here might be acute like I've drawn it, or it could be an obtuse angle, and this triangle would look very, very different. So that's the kicker, is on some of these you end up with a second possible answer. Okay? So we're going to go through 3 more because there are some other little twists that show up. Yes.
You might want to change that 2 to a 5.
What did I write down?
172.2.
Oh, it is a 5. Thank you. I did have a typo. It's a good thing you guys are paying attention. Okay, so let's get a little more interactive now. I know. So let's do number 4. Let's set up our triangle. We've got P, Q, R. So we'll do P here, Q here, R here. And you can put those wherever as long as you have P, Q, and R. And you do this. Measure of angle P is 108. I didn't draw this, so it looks obtuse, but that's okay. This is just a representation to help us figure out which angles go with which sides. And then we have lowercase r, side r is 10 inches. So here's angle r. Across from that would be where that 10 goes. That's where lowercase r goes. And then side P is 17 inches, so that's across from the big P. So this is going to be 17, and that's little p. And we're trying to find the measure of angle R. So we see what goes together. So 108 goes to 17. And the 10 goes with R, which is what we're looking for. So that's good. So tell me how to set up the law of sines.
Sine 108
Good.
over 17
Over 17, good.
equals sine r over 10.
Sine R over 10. Excellent.
And then cross multiply.
And then cross multiply. Good. So we're going to cross multiply. So this times this. So we would have 10 times sine of 108 equals, go this way, 17 times sine of R. How do we get the sine R by itself? Divided by 17. So we do that next. And then if I put that into the calculator, it comes out about 0.5594 equals sine of angle R. And then how do I figure out what angle R actually is?
What? Oh, the negative one.
Yeah, the one with the negative. So we're going to do inverse sine of 0.5594. And that's what gets rid of the sine, is doing the inverse sine. And when you put that in, it comes out about, so inverse sine of 0.5594 is, comes out about 34.01, something like that. So let's just go ahead and round that off to about 34 degrees for capital R. And then how do we check for a second possible angle R? Go ahead.
180 minus 34.
He was raising his hand, so I had to call on him. So 180 minus 34. So we're checking for the second one. So 180 minus 34, and that is 146. And we need to see if that's going to work with 108. Do I really even have to add those up to know that they're less than 180? Or that they're more than 180? I'm sorry, I said that wrong. No, that's going to be well over 200. Like, and I can already see that's almost 150, and I've got a little over 100. I can already tell by looking at that that that's a big fat no, because this angle is not going to work with the original 108 that we had. You cannot have two obtuse angles in the same triangle, so that one is a no. So 34 degrees is my answer, and that's it. Okay, so then on number 5, we're going to set up a new one. So we've got triangle EFD. So I'm going to put E over here, F at the top, D over here. I'm going to draw it just a little bit bigger. I don't know if I made much improvement, but we'll try. All right, and it says the measure of angle E is 61 degrees. Side D is 27 yards. So here's capital D. We'll go over here. 27 goes over here. And then little e is 25, so that's going to go over here across from big E. So this is 25. That's little e. And we set this up, so I still like to color code this while I'm teaching. The 61 degrees goes with the 25. And the 27 goes with angle D. So When we set this up, we'll have sine 61 degrees over 25 equals sine of angle D over 27. Go ahead and cross multiply. So 27 times sine of 61 degrees equals 25 times sine of D. Divide by 25 on both sides. And we put this into our calculator. It comes out about 0.9445-ish. And that would be equal to sine of D, because that's what's left on this side. Then we do inverse sine to figure out what the angle is. That'll be angle D. And it comes out about 70.8 if we round it off to the tenths. So 70.8 degrees is angle D. So we know for sure that one triangle exists and that we have one angle D. Check for the second one. So I'm going to put check. We're going to check for the second one by taking 180 minus 70.8, which gives us 109.2 degrees. And we check and see if that'll work with 61. So if I add that together, 109.2 and 61 does stay just a little bit under 180. So since this is under 180, that means that it does work. And this is where people make mistakes. This is the angle, is 109.2. We kind of add them up just to see if it's going to be under 180. You could do that mentally with a lot of these. That one you could probably do in your head and go, yeah, it's just barely under. But this would be your second angle D. So it could be this angle or it could be this angle. Okay, so we have one more. And I'm going to, we'll go ahead and set this up. There was something that I thought was going to happen on these that didn't, and I meant to change one of them, but oh well. So it says in triangle QRP, the measure of angle Q is 127 degrees. P is 35 inches, Q is 22 inches. Find the measure of angle P. So when we set this up, we've got QRP, so I'm just going to QRP. Measure of angle Q is 127 degrees. P is 35, which would be across from the big P, it's little p. And then little q is 22, so it's over here, and that's across from the 127. And we're trying to find the measure of angle P. So the 127 degrees goes with the 22, and the 35 goes with P. And then we go ahead and set this up. So sine of 127 degrees over 22 equals sine of P over 35. And we cross multiply. So 35 times sine of 127 degrees equals 22 times sine of P. If we divide by 22, you find out that you get 1.2705 equals sine of P. And then to get the angle, we do inverse sine of 1.2705. And when you type that in, what happens?
It says no.
It says no. You get an error. So when you get an error, you just know that there's no solutions. And you get to stop